Hi everyone. In this video, let's look at packet capture on a 9800 platform specific to Wi-Fi 7. So now setup is, like I have a test controller, Cisco 9800 cloud version, and I have a Wi-Fi 7 access point. So now I have few SSIDs configured. So one with the .1x, one with the WPA3 personal, and the other one is the OWE. So now Wi-Fi 7 point of view, at the moment, you have to have a WPA3 personal to get Wi-Fi 7 data rate. So that way now SSID being tested is the WPA3 personal, which is called MRN PSK. So now I have a couple of client devices. One is Wi-Fi 7 capable Intel BE200, and the other one is Intel X211. Which is not Wi-Fi 7 client, which is a Wi-Fi 6 client. To be precise, 6E. So now, if you deploy Cisco access point in a local mode, traffic will be tunneled back to the controller. So now this is different to the FlexConnect, where traffic will be locally switched. So that way, keep in mind, you can capture everything at the controller point. If you have a local mode deployment. In that way, assumption is you have the local mode deployment. So that way, now when you capture the packet at the controller level, so understand now we are capturing on the wired interface of the controller connected to the switch port. In that way, you will capture traffic twice, like once through the CAPWAP tunnel, and then traffic will be passing again to the same port, removing the encapsulation of CAPWAP. So that way, sometime when you look at the packet capture, it is not exactly same as the over-the-air capture. So keep in that mind, sometime when you look at the 9800 packet capture, you will see some additional encapsulation, CAPWAP, and certain traffic will be, same traffic will be without CAPWAP as well. That's because we are capturing on the controller connected interface. So now, in GUI 9800, you can go to the configuration, troubleshooting, and packet capture. And you can set certain parameters. More specifically, you need to configure the MAC address of the wireless client, because in a large environment, this WLC connected trunk port will generate a lot of traffic. In that way, you cannot capture everything and then filter it out. The way basically it works is you have to basically client MAC address need to be entered there. So now, just to compare this, I have a two over-the-air captures method as well. So in that way, I have a Cisco Meraki setup. So in that way, if my access point 9800 manage access point on the same channel numbers, I have configured. So Meraki AP is not broadcasting anything. It's basically using for capturing traffic. In that way, that's a one setup. And then I have a WLAN Pi as well. So this is also Wi-Fi 7 capable adapter is in same Intel BE200, but it only have one adapter. Okay, that way, sometime when you take MLO kind of captures, because of multi-link, ideally you need to have a multi-channel capture capability, but at least to, association happen only on one link. In that way, if you know what is that link, sometime even with a single adapter, you can capture the initial association frames, even though you're not able to capture everything, data frame including, but at least in that way, WLAN Pi also give a certain capability. So that way now you have to understand my setup, that way. So now let's look at what's the difference between pre-Wi-Fi 7 and Wi-Fi 7 client association. So now in the pre-Wi-Fi 7 scenario, we have example of this AX211 adapter laptop, and then connecting to the 9178 access point. So now this client also tri-band. That way it can use 6 GHz band, or it can use the 5 GHz band, or if needed, it can use 2.4. So now, whenever assuming they are using a 6 GHz band for association, so they will go through the SAE authentication. This is in the scenario of WPA3 personal. You have to authenticate first and then associate request response followed by the 4-way handshake. No differences, this is sort of a traditional frame structure, no difference made, because even though we have a tri-band, we always use one particular band to connect. So that way client MAC address will be 6 GHz specific MAC address, and then AP's point of view, BSS ID as well, single MAC address, no complication. If client basically using a 2.4 GHz, a client will have a different MAC address for the 2.4 radio, and AP's point of view as well, AP will have a different MAC address to the 2.4. So now if it is 5 GHz, they will use respective MAC address. So that way, like if it is a pre-Wi-Fi 7, no complication, even though it's a multi-band, any given time, they always associate with one band. There are no concept of multi-link operation. Okay, so that way it's a simple. So as long as you know the client MAC address, depending on the radio band, you can add that MAC address in 9800, you can capture the traffic. Okay. Now let's look at what's the difference in Wi-Fi 7. Okay. So now in Wi-Fi 7, so now again Intel B200, in here as well you have all this particular 3-band capability. But now in this particular scenario, when client associate, still they have to use one link to initial frame exchanges, authentication, association request response. But in this particular scenario, they will let the APs know they intend to use multi-link association. In that way, even the authentication frame, you will have something called multi-link element included. In that way, this frame has been enhanced to include the multi-link element. When the association request frame goes, client will let know AP, even though I am associating using 6 GHz link, I would like to get either 2.4, 5 GHz to my multi-link setup. So sometime AP can accepting those requests and give the allowing client to associate across all the link, or sometime if some configuration parameter mismatch, AP can dictate certain links can be accepted, certain links can be rejected. So that information goes in again basic MLE element in the association response frame. And that's followed by the 4-way handshake. But in this particular case, now 4-way handshake will derive some encryption keys, particularly for the unicast traffic and broadcast or group address traffic. Since we want to use the same key across any links, so now we need to have some common MAC address. In that way, to calculate the encryption keys, you need some upper layer MAC address, what we call UMAC. In that way, in the MLO scenario, yes, you still have the physical link level MAC address, but those MAC address cannot be used to derive this common encryption key. In that way, that purposes you are using something what we call UMAC or upper MAC, or sometimes we call MLD MAC address, multi-link device MAC address. So that way in this scenario, basically now addition to the physical link specific MAC addresses, you have what we call upper UMAC. Okay. In that way now certain key derivation process, we are using the upper MAC or UMAC address. But initial frame exchanges, we are using the link specific address. In that way, even this particular case, if you take the packet capture, you will see 6 GHz specific MAC address will be the source of a certain frame like authentication, association request, and M2, M4. They should go from the client MAC address to specific radio MAC address. In this particular case, 6 GHz radio MAC address. Sometime the key derivation process point of view, they will use UMAC address. Okay. In that way, now the question is, when we capture the traffic on the 9800 side, so what we expect to add as a client device MAC address. Now, like sometime client, this UMAC address, upper layer MAC address appears the client MAC address in the 9800. In that way, like normal, we add the client MAC address getting from the controller itself. We will add that, but even you adding that one, expectation is Cisco already know what are the UMACs for the client, and then they ideally should be able to get this MAC address detail from this. Okay. So now what I will going to do is actually show this particular difference between pre-Wi-Fi 7 and Wi-Fi 7 client association, and see whether it is what we get as anticipated result or something little bit different. By my testing, I identified something, that's why I'm not sure there's something to do with the software version or not, but at least I will show you. That way you can test your environment as well and see whether Wi-Fi 7 versus non-Wi-Fi 7 we get the expected outcome. So now to testing point of view, what I have done is basically I have two client devices. So I have in here, I have a Windows client with a Intel B 545C. It's the MAC address of that one. And I have another laptop, which is, it has a multiple adapter, but inbuilt adapter is AX211, having the MAC address of 3294. So now what we're going to do is, let me just log into the controller. And show you, so at the moment, no client connected, but I have added that AX211 client MAC address in the packet capture. If you go troubleshooting, packet capture, this packet capture pretty much entered the client MAC address, no difference, give a name, no filter, no need the control plane traffic. I have added the controller interface. This is the sort of controller interface connecting to the switch there. Okay. In that way, that's the setup. So now if you want to start the capture, you can simply start it here. Okay. So now at the same time, what I want to do is, actually I would like to, I said Meraki as well, we can take packet capture. Now I can, in Meraki, I go to the assurance, intelligent packet capture, and you can say new capture. Now I have a 2 access point, 9178, same as my 9800 managed controller channel numbers being configured. Then I'm selecting that, and I'm selecting wireless interface. Just to compare, I am taking this capture. I think 2 minutes is good enough. I will just basically name this as a Meraki. That's the packet capture method I'm using. 9K manage 9178. AX211, that's the client I'm connecting. That's the capture. So now this is also capturing, but I have not started the client connectivity. So what I'm going to do is now go ahead and connect the client. So now in here, if I go to the client, I can say go and connect to MRN PSK, which is my Wi-Fi 7 capabilities there. I just enable, just connecting to that SSID. Now you can see if I check that interface, you can see got connected on channel number 21. That's my 6 GHz configuration. In that way it's connected, already connected, that SSID, everything looks okay. I'm connected to that. And now, if we want, we can stop these both captures, like WLC1, stop the capture, and Meraki as well, let's stop the capture. So now Meraki packet capture, I just save like that name. So now 9800 side, you can export desktop. I will again, I will use this name, this is the name I use in the Meraki side. I will use this, because capture is taken from the 9800 itself. I will say 9800 here. That's a PCAP method, 9800 in that way. You understand, still AP is 9178. AX211. I'll just get that capture. Now let me just open so let me open those two captures and show one after the other. So let's look at the Meraki one, which is over the air capture. In that way, once you understand that, it is easy. For example, now I already given my sort of a profile to all of you in a previous blog post. In here, if you want to find out my client MAC address, those details, you can look at the association. And this is my Intel client 3294. I'm not worried about other association because it's a multi-channel. It captured that, but I am interested about this client. I just copy the MAC address of that client and apply to my client filter 3294, copy value, and I go ahead and enter to the client MAC address filter and replace this MAC address with my client MAC address. Now in here, if you look, you can see now this is a sort of a frame flow. For authentication frame, that is the WPA3 personal authentication, going from my 3294, my 6 GHz MAC address in the AX211 scenario, and to my Cisco AP BSSID MAC address, and then followed by association request, response, and 4-way handshake. No difference. This is the ideally what you should see. Okay. Now even if you go to the 9800 manage capture, let's basically open that capture. Now file open. Now this is the 9800 side packet capture. Now again, because same MAC address, the filter was there. So now again, if you look at here, pretty much same thing. Okay. For authentication frame, going from 3294 to BSSID or receive address 6BE9, and followed by association request response and 4-way handshake. But in here you can see the decrypted version of traffic. Why? Because controller getting a decrypted, encryption happen in the wireless level, AP to the client. But now we capturing traffic at the controller level. In that way, control after access point will be decrypting the traffic. In that way, you can get a decrypted view of the traffic. That's the advantage. Sometime disadvantage point of view, sometime all the frames are not here. Let me just remove this filter. You can see sometime like a beacon frame, certain control frame, those frames are not here because those are basically over the air kind of frames. No need to go to the controller level. In that way, when you're taking the packet capture at the 9800 level, it is not exactly simulating the over the air captures, but client troubleshooting point of view, you are interested about client traffic. Okay, not the management kind of traffic over there. In that way, troubleshooting point of view, this will be quite useful. Okay, now in this particular scenario, no difference. Like a client perspective, everything looks okay. No difference. Okay. Now what we are going to do is we are going to do the same thing with Wi-Fi 7 client. Okay. Now Wi-Fi 7 client point of view, let me go to my client first and let me just disconnect this client. Before disconnecting, let me just show you in our setup. So now at the moment, monitor client, only one client, 3294. Okay. Which is AX client. That's the one we took the packet capture. So that way, now let me just go ahead and disconnect this client, because I don't want to get complicated of multiple client capturing. I'm just disconnecting this client. In that way, no client on the controller. So this interface is now disconnected. So now what I'm going to do is I will go to the other Wi-Fi 7 client. I will get this 545C MAC address of this. This should be the client MAC address appearing in the controller. I'm going ahead and configure this as my MAC address in the packet capture. So now let's go here and I'm replacing this with my new client MAC address and update and apply. So now I am not capturing, I have not started the capture yet. So I will go ahead and now let's go ahead and configure your Meraki as well, just to capture again new capture, link capturing on the 9178 access point, wireless interface, download. Again 120 is good enough. This particular case I will name this as a Meraki 9800 9K 9178. That's my access point is 9178 on the 900 control, 9900 9800 controller. And this particular time I am connecting BE200. Probably if you want BE200, like a MLO client, Wi-Fi 7 client. In that way I will capture this as a BE200 like this. Okay, I will say go ahead and start capture. So now this is the over the air capture. I said I will use a WLAN Pi as well. I just show you that. So I'll go to my WLAN Pi and I selected my channel number 21, 80 megahertz. I will say start capture. In that way now this should give a two option of over the air capture, because I want to make sure both giving the same kind of thing when compared to 9800. So now 9800 as well, let's go ahead and start this capture. Okay, now all these particular three captures going on, what I'm going to do is I'll connect the client now. Okay, let me just minimize this. So now this is my client. So let me just go ahead and connect the client. Now you go to SSIDs, MR and PSK. It's here on the transition mode. I just want to connect MR and PSK and connect. Now you can see client got connected. Now if you check here on NetSH WLAN interface, you can see it's connected to MR and PSK. It's connected on channel number link ID 3, channel number 21. Okay, so at the moment it's not a MLO connection. Client somehow decided to single link. Ideally still we can check on the controller whether it's using a MLO or not, but it appeared to be client decided to only go for one link, but it's 11BE. Okay, that's the important part. So now let's check on the controller. Now if you go to monitor client, you can see now client basically it says MLO connection. Okay, so now you can see the MAC address is 545C, which is my client MAC address. If you click the client detail, you can see in this particular scenario this client capable of currently associating one slot. So ideally client can decide whether he need to go with 2 links or 3 links depending on the client capability. Ideally Intel B200 can associate across 2 links. Okay, but in these instances client decided to go with 1 link. That's okay. So he's only associating 6 GHz link. He did not really go for 5 GHz and 6 GHz. I know one potential reason. Okay, so potential reason mean basically I have another access point in the downstairs. Maybe he's originally went there and then came back. But anyway, now let's keep it simple and let's check what's the scenario there. Now I will stop these captures. So this is my so now in the Meraki captures as well. Okay, it says capture fail. That's okay. I will basically reproduce this particular test again, and just to basically finish the 9800 side, let's basically go ahead and stop this capture. Now we export. Now in this particular case I will use 98, we captured this in the 9800 side. I will use this BE200. Now save. So now let's look at, because now my Meraki thing did not really work, but this is what the WLAN Pi. In this particular instances, only anyway we can connect to 6 GHz only. In that way, this is also should give the full picture. So now in here as well, let's save this as well in that way, because I will share these captures with you guys. File save as, let's put into the same download folder. So now instead of using 9800, I will use AR tool. Again, it is 9K manage 9178 BE200. Okay, BE200. That's a sort of a packet capture name. So now in here as well, same flow. Look at the association request. You can see one association request and MAC address. You can see this is the important part. So now where this association request frame coming from? 545F. Let me copy the MAC address first. Copy value. Now where this is coming from, let me just show the 545F. Okay, 545F is my 6 GHz specific MAC address of the client. It is not the MLD MAC address. Okay, in that way, association request frame is going from the link specific MAC address. Not only association request, all this authentication, all these initial frame exchanges has to happen link specific MAC address. In that way, if you take the over the air capture, you can filter that by using the link specific MAC address. I will put that particular value there. And you can see this time as well when you filter. Same, you can see some authentication, there are additional frame has been exchanged. But if you look at in detail, sometimes this is the first authentication frame from client to AP. And then if you look at the detail, you will see it's like a authentication frame, SAE authentication, and somehow, you basically rejected. Okay. Status code authentication is rejected. The offered finite cycling, that particular group number may be being rejected. And then basically client is trying again. And this time he's indicating, yeah, these are the rejected group. I tried this, previously rejected. And then he is using a group number 19. Okay. In the first message, I think he's trying to do the group number 20. So now that is being rejected. And then he's trying group number 19. That's okay. I think this is a 256-bit, elliptic curve. Previous one is a 384-bit. That's what client tried. That's being rejected. Okay. But then for authentication frame exchange, you are successful. But now if you look at even this authentication frame, so you can see client basically adding some additional information element called multi-link element. And he is providing multi-link MAC addresses. Okay. Now this is the AP's point of view. This is the client point of view. Client sending multi-link MAC addresses. Now association requests as well. In this particular case, client basically, let me collapse all. And he's sending multi-link element. In this multi-link element, if he willing to add additional links, he need to provide that information. But in this example, we saw a client connecting only one band, no additional link, no station profile added here. Okay. So now AP basically responding, saying that, association response. Again, multi-link element will be there. But if you look at the multi-link, this control command info, you should see this is like a successful kind of association. No additional station profile is there. Otherwise, whether we are accepting additional links or not will be available under station profile. Okay, in here there are no station profile, but now you see it is followed by 4-way handshake, and that is your traffic. Okay, now this is what you expect to see: link specific MAC addresses and link specific MAC addresses at the AP side. So now let's look at the packet capture we took from the wired side. That means on the 9800 side. If you check 9800 side, we took this B200 packet capture. Now sometimes this filter, like that's the thing you need to be careful about. Ideally, I should be able to see this frame, but you can see there are no frames originating from client, at least MAC address specific. Okay, that's the one thing, bit of worry. So now in here, if you want to find it out, if you filtered out, you can see now initial frames. You can see here authentication frame. You can see like association. Sometime you are not getting all the frame being captured. That's one thing. But now in here, if you look at the receive addresses, okay, most of these receive addresses appear to be MLD MAC address, which is not right. Okay, that's the thing. Now if I basically minimize this, because I want to make sure you have a clear idea with the diagram now, at least in that way it can make more sense. Now if we look at, now this is a scenario with the MLO kind of scenario. Now 545C is my upper layer MAC address. Okay, none of these frames should intended to this MAC address. In that way, now this is like 6B E9. Okay, 6B E9. So now let me just check what is the 6B E9, because this diagram may be in my PowerPoint, maybe not up to date. Let me just check in the controller point of view. If you go to the monitor client, now if I click this particular client detail, go to this view additional detail. So now you can see, now in this particular case 6B E9 is the 6 gigahertz specific MAC address, BSS ID. Okay, so now station address link MAC address is 545F, which is right, but this is MLO address. In that way, now what's happening is now this MAC address, link 3, I don't think I got it right. This is this value is the right value. Okay, so this is the right value. 6B69, this one is not right. This may be a different client. So you get the idea. In that way, now you can see these frame appear to be receive address appear to be the client address, MLD MAC address, which is not right. In that way, my gut feeling is, maybe they are rewriting some MAC addresses or certain things in the frames, because it's supposed to see the this MAC address 545F. Okay, in that way, because I filtered by this MAC address, it does not appear to be. Now we can do the testing again with the just to this link specific MAC address, but you can see this time every frame, most of the frame has been captured, but not everything I would like to see, and the right addresses. Okay, in that way, that's the one issue I noticed. I have tested with the 1715 code version and 1718 version as well. I observe the same behavior. Okay, now just to see what other sort of MAC addresses being now what we can do is, I will go back to that MAC address. I will get this client MAC address, this link specific address, and capture one more time. So let's go to the same troubleshooting packet capture. You understand, we added the client MAC address, but that's a upper layer MAC address, UMAC, but traffic should not be received by that MAC address, but that's what I can see. So now in here, what I'm going to do is to see instead of the upper layer MAC address. So now in the GUI, you cannot add multiple MAC address. So if you want to do this, you can issue the same command in the CLI. I'll probably do a separate video on that because otherwise this video getting too long. I'm just for the time being just to show in this particular single MAC address. But before go ahead and start capture, let me go ahead and disconnect the client. Okay, let's go ahead and disconnect the client. I will go ahead and disconnect client. Okay, now disconnect the client. In that way, now whenever I'm starting capture again, now you can start the capture. Start by camera. I'm using that interface. I'm connecting to MRN PSK. Now it's connected. Still, we can see client basically happy to stick with the one channel. That's okay. Now let's go and see what's being captured on the controller. So now I stop the capture and export. I will export. I will give the name 9K I will give the 9K, not Meraki, 9800 B200, but in this particular case I would say LMAC or something like that, lower MAC address. I give a link MAC address. Now if I open that capture, now you can see that's giving a certain frame in the previous capture we were missing. Okay, that means like association request frame. Now if I go back to the previous capture, we didn't see the association request frame. Okay, now you can see certain frame going from the client. We can see in that way. If you want to capture those frame, you have to add the this MAC address. Okay, now in that way my gut feeling is now in the controller side. Now if I go back to the previous capture, file open, listen this capture. Now this capture you can see it's only showing the traffic coming from the Cisco AAP side transmit address, because no traffic is originating from the upper layer MAC address of the client. So you are missing certain traffic. In that way, now the issue is, I think, like I can get some feeling for it. Like now what we are anticipating is, like whenever we go to monitor client, whenever we select this interface, even though this is a upper layer MAC address, we anticipate Cisco to find out the link level MAC addresses and capture traffic of all those link layer MAC addresses as well. Okay, that's a Wi-Fi 7, like a multi-link operation is something to Wi-Fi 7. In that way, it appear to be current code versions, like they're not doing it right. Okay, that mean I'm sure, like hopefully, either somebody else may have already reported this issue, or if not, basically after seeing this, I'm sure Cisco will fix it. Okay, in that way, I'll do some more testing as long as newer code version comes. So as you can see, this one I tested with the 17.15.3. I have another sort of controller 17.18. I tested on both controller. In that way, same issue. That's I would expect, like whenever you are in summary in that particular case, if you have a a packet capturing mechanism where you need to filter client MAC address, so be mindful about how it exactly work, because all this particular initial frame will go link specific MAC address, even though we have a common MAC address called a multi-link level MAC address, MLD MAC address, that is not being used for any frame exchanges as a source or destination or transmitter or receiver. So it always goes from a link specific MAC addresses. But now we use Meraki and other WLAN Pi. In here, there we are not controlling or filtering traffic, a particular MAC address. We are capturing the entire channel traffic, so you will get everything. Okay, but this is specific to if your capturing tool have a MAC address based filter. Be mindful about which MAC address need to be added. In the usability point of view, we are anticipating user will click on this MAC address on the controller dashboard and get it done. But ideally, vendor specific implementation should match every MAC addresses there and give that as part of the capture. I would like to see everything. Okay, at the moment it appears to be a bit broken, but I'm sure Cisco will fix it. But I'll let you know if I find it out in upcoming releases if this has been fixed. Okay, so hopefully you get the idea. In that way, make sure you know the capability of where 9800 can be used for packet captures, but understand what's being captured, where, and then what are the limitations and what are the advantages as well. Okay, I hope a video helpful. Until I see you again, take care.